So now we have a quadratic equation because we have cos squared, but we also have another cos. So you're going to either have to factor or use the quadratic formula. When I have an equation like this that's either factoring or quadratic formula, we need to make one side equal to 0. I always like to make whatever my term is that's squared positive. So I'm going to move that over, everything over to the left-hand side. So I added 3 cos squared and subtracted 1 over to the left-hand side. And now I've got a quadratic equation. Now, one of the things you want to get good at is factoring. And looking at this equation, how quickly can you notice that it can't be factored? Okay? If you can, okay? So one of the things, though, you want to be good at factoring, but if you get an equation, especially these ones where you have a number in front of the squared, they're the hardest ones to factor. If you can't recognize right away that this can't be factored, or if it could be factored and you can't recognize right away how to factor it, you have your quadratic formula. Your quadratic formula always works. So it's not wrong if you use the quadratic formula when you didn't need to. It's not wrong. It just might have been a little bit longer, but maybe not for you. Maybe it's still faster for you than factoring. So now my quadratic formula would say x equals, but since it's cos that squared, we'd write cos x equals negative b plus or minus b squared minus 4 times a times c over 2 times a. And simplifying this, negative 1 plus or minus square root of 13 over 6. Which we can split up and write both of them down. So one of them is going to be negative 1 plus the square root of 13 over 6, and the other one's going to be negative 1 minus the square root of 13 over 6. So we need to go to our calculator because obviously that's not on our pie plate. Negative 1 plus the square root of 13 divided by 6 is 0.434. Okay, we need to find our reference angle by doing cos inverse of that answer. And since that answer is already positive, we get 64.3 degrees. Are we in degrees in this question? No. So I have to go and go, oh, need to change to radians. Cos inverse of this value, 1.12. is my reference angle. And so x would be, and the question said, use algebra. It didn't say to how many decimal places. So x would be 1.12 in quadrant 1. And go back to my calculator. Cos is also positive in quadrant 4. So 2 pi minus my reference angle, 5.16. I guess technically, since they didn't say how many decimal places, you should go 3 decimal places. 5.162 and 1.122. So those are the answers for the first equation. The second equation, type this into my calculator. Negative 1 minus the square root of 13 divided by 6. negative 0.768. Find my reference angle by taking this value, but I need to make sure it's a positive answer, so I'm just going to multiply it by negative 1. My reference angle is 0.696. I'm going to store that as x. Now I have my reference angle stored as x. Cos is negative in quadrants 2 and quadrants 3. So 2.446 and 3.837. I like to make this note that these are solutions between 0 and 2 pi. If this was what the question asked, I'd be fine and I'd be done. But by making that note, I'm reminding myself to go back and check the domain. Oh, and their domain is between negative pi and pi. So we do have to change our answers. So the domain was negative pi less than or equal to x less than or equal to pi. Just making some notes here. Here it was quadrant 1. Here it's quadrant 4. Here was quadrant 2. Here was quadrant 3. So if I'm going from negative pi to pi, which of these answers do I have to take out? Quadrant 3 and quadrant 4, because they're too far. So I'm going to, this one and this one are going to be taken out. For my final solutions for x, x is going to equal, well, I can keep the quadrant 1, I can keep the quadrant 2. Quadrant 4, 1, would you agree that that would be the same? I should do quadrant 3 next. Just quadrant 3, 1, would you agree that that would be the same as the quadrant 2, 1, but in the negative direction? Because it's two quadrants, same reference angle. And the quadrant 4, 1 would be the same as the quadrant 1. Quadrant 1, 1, but a negative direction. And so there we have our final answer. Part B says to write the general solution. I would take my four answers between 0 and 2 pi. 1.122, 2.446, 3.837, and 5.162. Add 2k pi to each of them. Where k is an integer. Whew. So as soon as you get to calculator, it's just more tedious, right? Because you have to do more work to get your answers. You have to work with your reference angle longer. It's a little bit more tedious. The answers don't look very nice, but it's the same process over and over again. So once you get really good with that process, you're going to find that even these ones where you had to use the quadratic formula and do lots of work, you're going to be able to do them. So questions 14, 13, and 12, mixing things up this time for practice. 14, I think a lot of 14 you can actually factor, but you can use the quadratic formula if you would like.